Here's a geometry joke to kick things off. Why did the parallelogram cross the road? To prove it wasn't a trapezium. Now, when you're working with shapes in geometry, especially quadrilaterals, it's super helpful to understand how to calculate their areas. In this lesson, we're diving into the trapezium, or trapezoid if you're across the pond. It's a four-sided shape with exactly one pair of parallel sides. This makes it kind of like a cousin to the parallelogram, but with its own twist. We're going to learn how to calculate the area of a trapezium using a formula, and even better, we'll explore how that formula is built from scratch. So it's not just memorizing, it's understanding. Let's get started. Feel free to pause the video if you need time to think. A trapezium is a quadrilateral with exactly one pair of parallel sides. These two sides are called base 1 and base 2. The height is the vertical distance between them. It must be perpendicular, not slanted. Now, the area of a trapezium is given by this formula: 1/2 multiplied by the sum of base 1 and base 2, and then multiplied by the height. In other words, area equals 1/2 times open bracket base 1 plus base 2 close bracket times height. Let's turn to the next slide. Let's try that out with some real numbers. Imagine a trapezium where base 1 is 10 centimeters, base 2 is 6 centimeters, and the height is 4 centimeters. Using the formula, area equals 1/2 times open bracket 10 plus 6 close bracket multiplied by 4. That gives us 1/2 times 16 times 4, which equals 32 square centimeters. So you can see how plugging values into the formula gives you the area. But where does that formula even come from? Let's explore that now. To understand the origin of the formula, let's begin with one trapezium. Just one. It has its two bases, base 1 and base 2, and the perpendicular height going between them. We're going to manipulate this shape a bit to help us discover a deeper insight into its area. Feel free to pause if you want to visualize this a bit longer. Now we duplicate the trapezium, make an exact copy, but this time we flip it horizontally like a mirror image. We'll be using this flipped version in the next step and combining it with the original to create a brand new shape. Let's turn to the next slide. Now comes the magic. We place the original and the flipped trapeziums together. When positioned just right, they form a new shape, a parallelogram. What's the base of this parallelogram? Well, it's made up of base 1 from the original and base 2 from the flipped copy. So the full base is base 1 plus base 2. The height of the parallelogram stays exactly the same. That vertical distance hasn't changed. This setup lets us calculate the area of the parallelogram and helps us understand the area of just one trapezium. Let's turn to the next slide. Because the two trapeziums together make one parallelogram, we can now calculate the area of the full shape. The area of a parallelogram is base times height. In our case, that's open bracket base 1 plus base 2 close bracket multiplied by the height. But remember, this parallelogram was made by combining two trapeziums, so the area of just one trapezium must be half of that. And there you have it. Area equals 1/2 times open bracket base 1 plus base 2 close bracket times height. Now that you know how it's built, the formula hopefully makes much more sense. Let's move to the final thought. To wrap it all up, a trapezium is a four-sided shape with exactly one pair of parallel sides. The area of a trapezium is calculated using the formula 1/2 times the sum of the two bases multiplied by the height. We saw how that formula can be derived by turning two trapeziums into a parallelogram. Understanding the geometry behind the formula gives you a stronger grasp of what's really going on, beyond just memorizing a rule. Keep practicing with different trapezium shapes and numbers. The more you try, the clearer it all becomes. Thanks for watching. Don't forget to like the video, subscribe to the channel, and stay tuned for more mathematical adventures. See you next time.